Okay, so this is for 9.2, day 1 of 9.2. The homework I think I gave you was what? 1 through 6, and then 7 to 24 E odd?
23 odd, yeah.
Okay, 23, yeah, that makes sense. Okay, so first, I don't think I have to go over identifying A, B, and C. So why don't we just start with number 7? So number 7, it asks us to tell us is it open upwards or downwards? And then also to find the axis of symmetry, okay? So that's y equals x squared plus 6. So we
Number
can start by
7.
identifying A, B, and C. Now, A is the number in front of x squared. There's no number we see, so we're going to imagine it's 1. B, it would be the number in front of just x to the 1 power, but x to the 1 power doesn't even exist at all. So it's kind of getting multiplied by 0. So there's none at all, so it's 0. And then C is the number by itself, no variable, so that's 6. Okay, so the first part of the question is tell us whether it opens upwards or downwards. We could tell when something opened upwards when A is positive. So when A is positive, it points upwards, or it's like U-shaped, you could say. If A is negative, it opens downwards. So in this case, it's positive 1, so this opened upwards, so upwards.
That's the answer.
This part of the question is ask us to find the axis of symmetry. Now remember, from today's lesson, the axis of symmetry is simply the x value of the vertex. So we don't even have to find y, we'll just find x. And we could find x by using negative b over 2a. Well, something's really nice. B, we found out, was 0. So negative 0 over 2 times 1, it doesn't matter what's in the denominator.
Negative
Okay.
b over 2a.
Negative b over 2a. Make sure you get that equation down.
Wait, why?
That helps us find the x of the vertex. And the axis of symmetry is also the x of the vertex. So that equation is important. That's the main part of today's lesson, was the negative b.
That's true.
So 0's on top, so it makes the whole thing 0. So your answer is upwards and 0 for like number 7, okay?
So that's the answer.
Yeah, for number 7 at least. All right.
Okay, you go over number like 1. Like
1?
those. Are those just the same thing we used to do, like 7 times 11?
No. You're not even doing that. You literally are just telling me what's A, what's B, and what's C, and then you're done with that question.
Oh, that's all it is?
That's all you need to do from 1 through 6.
And then 7 through 20.
7 to 15, you're going to tell me that upwards and downwards and the axis of symmetry, which is just the x of the vertex. For 17 to 23, though, 17 to 23, when it says find the vertex, I want you to tell me what the vertex is, what the axis of symmetry is, what the min or max value is, and what is the y-intercept. I guess I should put that in the instruction as the y-intercept.
So what
So
we
let me
used
do
to do.
something from 17 to 23, okay?
So 7 through, right, let me just repeat that. 7 through 23, we're just finding the vertex, the axis
No.
of
17 to 23.
17 through 23, we're just finding the vertex, the table.
No table. Not table today. We'll do that next time.
We're finding the vertex and the
Axis
axis
of
of symmetry.
symmetry. We're going to also find the min or max value. And we're going to also find the y-intercept. But only the vertex is the only one that takes work, okay? Everything else comes for free, basically.
Yeah.
So I'm going to pick number 19, okay? Seems a little tougher, okay? Actually, let's see. Is there any fractions here? Because I know both Rebecca and Dear asked for help with fractions. It's not on this page, so we'll do that another time. So let's do negative x squared plus 4x minus 2. This is number 19. So our first step is just identify ABC. Sam, why don't you tell me what ABC is in this one?
A is -1. B is 4. And C is -2.
Good. So with that information, we could find everything we need to find. First off, we're going to find the x of the vertex, which we use this equation, negative b over 2a.
So it's negative
So that's going to be negative 4, because b is 4, over 2 times negative 1. So that's negative 4 over
negative
negative
2.
2. And then when you reduce
Positive
it,
2.
positive 2, yes. So that is my x value, okay, of my vertex. Now, just like any equation, we've done this a couple chapters ago, when you're looking for the y value, you take your x value and plug it in. So we're just going to plug in positive 2 into all of this. It's very important to know it's like a negative 1 times 2 squared. So you do 2 squared first, then times it by negative 1. Don't do negative 2 squared. I know that's a mistake sometimes we make. Plus 4 times 2 minus 2. So 2 squared is 4, then times negative 1 is going to be at negative 4. 4 times 2 is going to be at 8. And then minus 2.
2.
So negative 4, yeah. Negative 4 plus 8 is negative 4, or positive 4, I'm sorry. And then minus 2 will give you 2. So 2 is y. They happen to be the same number. They're not always the same number. So our vertex is an actual coordinate point. So it's 2, 2. It's not just 2. It's 2, 2. Our axis of symmetry is the x of the vertex. So it's this one right here. Happens to be 2. Our min or max value is the y of the vertex. That happens to also be 2. And then our y-intercept. Our y-intercept is very easy. It's just the c value. The c in this question is negative 2. We are done. So this is what I need to see for your answer, okay? In the red.
All right. That's all.
Okay.
Thank you. I'm going to go and
No
do
problem.
it. Thank you.
Adira, Rebecca, do you have questions on this section?
Okay, so yesterday, like, that whole, like, section, like, I'm pretty sure, like, I did the first part right.
Mm-hmm.
Like, there was, like, fractions in the problems, and I was just really confused because, like, at the end, like, my graph looked like it had parabolas on it, and it looked, like, fine. But then like, a lot of the answers I was getting, like, in the, like, when trying to figure out the domain, like, weren't, like, whole numbers.
Yeah, like a lot of my answers was like for one of them, I got like 10 and 4/5, 10 and 1/5, and then like 10.
And, like,
Okay.
numbers.
That's if you are starting with a fraction, you will get fraction results. As long as your domain is -2, -1, 0, 1, 2, your results could vary to fractions. That's possible. So why don't we do that? I just want to ask, do you have any questions on 9.2? Because I would like to separate the big from 9.1.
No.
Yeah, because I
didn't understand this at all because I think I'm also just like really confused from like still 9.1 where it's like I can't understand this yet.
Okay, so why don't we start with 9.1 and then go back to 9.2?
Yeah.
Okay, so I cleared that. So let's look at 9.1. I'll look at yesterday's homework. All right. I'm just trying to open it up on a different tab for myself. Okay. So what did I ask you to do though? 24 to 32?
Yeah.
Yeah.
And like the fraction started on 29.
Yeah, like
So
the
let's do a
first C like I got. But
okay. So
we
let's
do
do
32.
And
30. Which one? I can start at 29, 31, 32. I don't care.
31 and 32 are like the ones we both struggle. Like I struggle with 31, she's struggling with 32.
Okay, let's do 31 and 32 together. So 31. So the 31 question is a half x squared minus 5. So let's see. So our domain is always the same in these questions.
Wait, do you not have to write the y?
What line?
The y.
I'm being lazy, my bad. Yeah, it does equal y. So x and y, -2, -1, 0, 1, 2. Thankfully, that always stays the same for this section, and it's pretty simple. So now we're just going to plug in. Now, I want you to keep in mind, remember, this is symmetrical. So if I find one of these here, I find the other one across of it. So I actually only need to find 3 answers. This one, and this one. Because the other 2 come for free, basically. So let's do one at a time. So we're going to do this one first.
Okay.
So I can rewrite this, and maybe this helps you out if you rewrite it as x squared over 2. That might be helpful.
You
Minus
know what?
1,
I just like took like 4 over 1 and did it like that.
4 over 1. Oh, I see what you
Yeah.
mean.
Why
That's
did you
also,
put-
well,
why
4
did
over
you-
2 you mean, right?
Why do you like change?
No, first I did 4 over 1 and then I did it times a half and then I got 2.
Oh, yeah, that's fine. That's fine. Okay, so maybe I won't do it like that. Let
I
me
don't
just
get
flip
why you put x to the second over 2.
it. Then let me just keep it like this then. Okay.
Wait, is it just like because you would put it over 1 in the and then it's already 1, so like multiplying it you would have.
That's why I would do it like that, yeah. But
Okay.
it might be just easier for us to do it like this. So first one is -2. Adira, what's -2 squared?
4.
4. Now, so that's going to be, it's -2 squared is 4. So now we're going to have 4, and you could rewrite this as 4 over 1 times 1 over 2. You could also just type in your calculator 4 times what's 1 over 2 as a front decimal happens to be a half. -5. So 4 over 2 reduces down to 2.
When you multiply fractions, do you have to have a common denominator?
No, when you multiply fractions, just numerator, numerator, denominator, denominator. No
And
need
when you
to-
add fractions, do you have to have a common denominator?
yes,
Okay.
add or subtract. So 2 minus, I was a little ahead of myself. 2 minus 5 is end up going to be -3. So this value right here is -3. Okay. The next one I can see already is going to cause a fraction, and that's okay. Sometimes your answers are fractions, especially if you're given a fraction. So 1/2. This time it's 1 squared, or -1 squared. Oh, and since we got -3 here, we could also write -3 here.
Yeah.
So -5. So it's 1 over 2 times 1 over 1. Or anything times 1 stays the same.
Yeah, I didn't like do that part. I just
Oh,
kept
so
it because it
it's
was
just like
one.
half of. Is it just like half of 5?
Yes, half minus 5. If you're unsure what the decimal is, you literally type in your calculator 1 divided by 2, and it'll give you the decimal.
Is it?
So if you're ever unsure, like the next one is like 2 over 3, you just do 2 divided by 3, and then you could just get the decimal from there. But let's go. 1/2 minus 5, that should be -4.5.
Oh, that's what I got.
Yeah.
Not get that. I got 6.5. I don't know how.
6.5. You might have added, but then added a little off.
Maybe. Probably.
No, I know what you did. First, you did 1 plus a half instead of 1/2 time. I'm sorry. You did 1/2 plus 1 in accident. That gave you 1.5, and then you added it to 5.
Okay. Yeah.
Okay. So this is 4.5 or 4.5. And then this one comes for free.
Like the vertex is just -5, right?
Yeah, now the
it
vertex,
cancels it out.
this thing becomes 0. So it's just whatever left over, which happens to be -5.
Oh, I see. Because for this one, when I drew my the parabola,
It will be like a
because I
W kind of shape. I
yeah.
imagine. Yeah.
So I was just confused.
Yeah, so if you do graph your thing and you get like a W shape, you made a mistake. So it's a really good way to check your work. And just a general graph.
Yeah, it happened to me like 2 times before because I like put it like in positive instead of negative.
Okay. So your U shape should look like something like this, where the vertex is very particular. The vertex is underneath the x-axis, so somewhere below here, and kind of just goes up like that. Maybe a little bit, the big drawn a little bit better, but. A little bit sharper, probably. Okay. All right, so that's 31. Now, it does ask us, part of the question, to compare it. So when the A is a half, does it become thinner or wider?
What? When the A is half?
Yes, it's less than 1 in this case. So does it go up faster or up slower?
No, it's more
It's wider.
narrow.
It's wider because think about it. It's going
Oh.
up slower, so it takes a little bit longer to get to the top, right? So it's wider.
Wait, that makes
Oh,
so much sense.
yeah.
hmm So it's going to be wider. And I think it asks you the shift. So did it shift up or shift down?
Shifted down.
It shifted down. And you could tell that from the C, which is -5 in this case. Because if it's -5, it literally takes the graph and drags it down 5 units.
Wait, is that like when you do, like when we were graphing lines before and like we'd have to find like the slope? But this is, it's kind of like that, like instead of like the slope, it's like,
yeah, this would be more associated to like finding the y-intercept. It's like the letter B back then was the y-intercept, so that was your y-intercept. This one, in this case, the C tells you your shift. But it is graphing stuff, and the numbers do change it in a certain way. Okay.
All right. Can we do 32? That one like was really bad for me.
Yeah, so you're dealing with 2/3, which is going to make it a little awkward. And let me just at least write the problem for myself, and then for anyone who's watching on YouTube. -2/3 x squared plus 9. Okay. Jeez. Right. Make our table. X, Y. -2, -1, 0, 1, 2. And then you have your y values. So your y values we have to find. Again, we have a little bit of a shortcut. If we find -1, we find +1. If we find -2, we find +2. So we technically only need to do 3 things.
I'm not on mute.
So -2/3. We're going to plug in the first one, which is -2 squared plus 9. So -2 squared is still 4, and I'm going to put it 4/1 times -2/3. -2 times 4 is going to be a -8 on top, and then 3 times 1 is just a 3 on the bottom. Now we're going to add the 9, but the issue is 9/1 does not have the same denominator. So what can we do with the 1 to make it match? Either one of you could answer. What do we do with the 1 to make it match?
You do like times 3.
Good. So when you times 3 on the bottom, you times 3 on the top. So over here, -8/3, it's okay because it's already at it's where it wants to be. 9 times 3 ends up being 27/3.
Oh, so I think I got it right because I think that's what I did, but it was just like really weird numbers. So
Yeah, you're gonna get either 0.3 repeating or 0.6 repeating. That's just gonna happen with divided by 3.
I got 6 1/3, I think.
Well, so -8 plus 27 is so it's 27 minus 8, so it's 19/3. So you could write just 19/3, but that's kind of hard to graph. So let's change it into a mixed number. 3 goes into 19 6 times. 3 times 6 is 18, and then there's only 1 left over. So 6 1/3 should be your answer.
Yeah, that's what I got.
Good. And if it's there, then it's also here. So let's see. Or whatever. So if it's over there, it's also over there. Let's do our next one. Change the color, so we're doing yellow. What the? Let's make this smaller. Okay. So in yellow, -1 squared. So the whole same thing, except now it's a -1 instead of a +1, or -2 plus 9. Now -1 squared is 1, and then 1 times anything stays the same. So it's -2/3. So -2/3 plus 9/1. but you already did the work to change it into base 3. So we could just look at this one over here. So I know this is the same as 27 over 3 plus negative 2 over 3. Negative 2 plus 27 is the same thing as 27 minus 2. So that's 25 over 3. While you could leave it as an improper fraction, it's hard to graph that. So let's do 25 over 3. 3 goes into 25 6, 7, 8 times. That's 24, and there's just 1 left over. So 8 and 1/3. So it's 8 1/3. And then this one is also 8 1/3. All right, plugging in 0 is the easiest part. Basically, you don't even care about what's the x connected to. You just take what the c is. So that happens to be 9. Now your graph should be looking like this, kind of like whoop, and then kind of like whoop. Okay. So it does ask us to compare our x and y's, or compare it to x squared. So very notably, instead of it being upside right, it's upside down. So one thing we're definitely going to describe it is upside down. Or you could say it opened downward. So the opening is downwards, which is the verbiage they use in the homework tonight. And then the second part is it shifted up or shifted down? Because it's a +9, it got pushed up 9 spaces. So that you could say it's shifted up. Like that.
So like something could be like shifted up, but like down, like upside down.
Yeah. So it's like you flipped it upside down first and then pushed it up.
Yeah, okay.
Yeah. And you could tell something's upside down simply by this. If you see the A is negative, that means it's upside down, okay?
Can you
All right.
do like an example problem from like 9.2?
Sure. It's all right if I just open the homework and pick one of those. So let me open up the homework and pick one of those. Okay. Okay. So let's do number, what's a tough one? Why don't we do number 21 on the homework, okay? So 21, they ask for a lot of things, or I'm asking for a lot of things. It is y equals -2 x squared plus 8x minus 3. So we're going to need to find 4 things: vertex, axis of symmetry, the min or max value, and the y-intercept.
Is this like steps, like what you have to find first?
Yes, it's the steps that I'm pretty sure I wrote onto the thing.
Okay.
Yeah. So I'll use exactly the steps it says. So step 1, identify A, B, C.
So is the B like the 8?
Yes. So A, why don't you tell me all of them, Rebecca, then?
Okay, A is -2,
Mm-hmm.
B is 8, and C is -3.
Good. Now, I'm going to ask Adira, what is the equation we use to find the x of the vertex? Did you watch the video today?
I started it and then I was just confused because I like didn't understand what
That's fine.
last lesson.
So this equation you want to write down -b over 2a. And then put next to it x of the vertex. So this is the equation we're going to use. So I'm going to plug in my numbers. B we identified was 8, so it's -8 over 2 times my a identified as -2.
Wait, what's the negative b to a thing?
This equation finds the, and I'll just type it so it's a little clearer, the x of the vertex. Okay? So that is the equation to find the x of the vertex. So it says in step 2, plug in and solve negative b over 2a for the x of the vertex. So the x of the vertex is -8 over 2 times -2, -8 over -4. Adira, what does that reduce this to?
4 over 2.
Which could reduce even more to?
2 over 1.
2 over 1. So we're just going to say 2.
Positive because they're both negative.
What's up?
Is it positive because they were both like 8 was and 4?
Yes, it's positive because the negatives cancel out. Okay. So in this question, 2 equals x. Now what we're going to do is take that 2 equals x and take it and plug it into here to find our y. Just like if we done back in when we were doing slope and y-intercepts, just like we done when we first started graphing. We're going to take our x and plug it in to solve for y.
Is it going to be like both x's or only like one of the x?
Both x's. Every x becomes the 2.
This makes so much sense.
I'm happy to hear that. So -2 times 2 squared plus 8 times 2 minus 3. Okay, 2 squared is 4. 4 times -2 gives you a -8. 8 times 2 is 16. And then minus 3. -8 plus 16 is just an 8 minus 3. So 5. So 5 is my y value. Okay. So my vertex is a point on a graph, and that point is 2, 5.
That's
So that point is 2, 5. Now, the axis of symmetry. Every parabola, this happens for every parabola. So let me just draw a generic parabola. Every parabola kind of looks like a U shape. It could be upside down or right side up. It looks like a U shape. Every parabola is symmetrical. And let me make it a dotted line to show that it's kind of like, it's not necessarily the y-axis. Every parabola is symmetrical in the middle. The right side matches the left side. So what we call that line, that vertical line, is the axis of symmetry. This is where they're symmetrical around. But notice that axis of symmetry is exactly at the vertex. So the axis of symmetry happens to always be the x of the vertex. So it's always the x value. So the x value in this vertex is 2. So the axis of symmetry is just 2 because the vertex x is just 2. That's how simple to find it.
Wait, for like all those things on the side, V like for the vertex like spot.
Yeah.
And then what's the second one? What is it? Like I can't read it.
Axis of symmetry, AOS. So I shorthanded it. But that's called the axis of symmetry. And I think in the, from 7 to 15, you can see how it's spelled, because I don't know how to spell offhand. All right. Next one is the min or max value. Now, let's look at this again, this generic parabola. When it's upside right, there's a point where the graph goes its lowest possible point. Again, that happens at the vertex. And I also want to point out, if it was upside down, it goes to its maximum point. So that's the max. It still happens at the vertex though. So there's a minimum point here and a maximum point here. So the min and max point is how high or how low it goes. And what variable do we use to measure how up something went or how down something went? We end up using the y variable to measure that. So the min or max value is the y of the vertex. So it's simply going to be whatever you found the vertex y to be, which is 5. So literally, if you find the vertex, you get 2 for free on top. So you got to make sure the vertex is the only math part of it. Everything else is just plugging in information. Now the last one is the y-intercept. So the y-intercept for this is where it hits the y-axis. Do you remember what x has to be? I'm asking you guys, so one of you answer. What does x have to be that it hits the y-intercept?
0.
0.
Good, 0. So when I plug in 0 into this part right here, what happens?
It's 0.
It's
It
0.
cancels.
Yeah, it just cancels out. What happened when I plug a 0 into here?
Oh, so it's gonna be the C is the y-intercept.
So wait, what if the x was like on the C, so then it'd be 8?
If the x was on the C, then it would stop being the C and start being the B. You know what I mean? It's the C by definition is the letter by itself with no x's.
So are there problems where it's like not in that order? So you would like put it in like A, B, C?
Like would I put it in like B, C, A order? I could technically do that, but we don't usually do that because the natural order is A, B, C. So we don't do that on purpose.
So like the problems in textbooks are always going to be A, B, C.
It should be A, B, C always. But like number 17, notice, like if you look at number 17, which is negative x squared plus 3, it doesn't have a B. So B would be 0 in that case. So sometimes you don't see it though. You know what I mean? It's still A, C. It's still in order though.
Yeah.
Okay. So your C value.
Do we still have to do the table for these problems?
Not today. I don't want you to practice on that today. We're going to do that tomorrow. But the table's there's a different rule for the table, so I haven't taught you.
No, what I'm saying, like on these problems. Okay.
Yes,
Okay.
but in this section, the domain is not always -2 to 2. I will teach you that next time. You don't know how to do it yet, okay? So -3 right here, this -3, or your C value is always going to be your y-intercept. So you don't even have to think about plugging in 0. You could just plug in, or you just know it's going to be C. So your answer for this one is -3. In the red box is what I expect to see for your answer for these questions. And that's the answer for number 21, wasn't it? Good. So how do you guys feel after getting actual live teaching versus the videos?
A lot better.
Yeah, I think this is like better than this year.
Yeah, because like in the video, I can't like ask questions really. So then I just like have to rewatch it 1,000 times, and then I still like.
Okay, so I think I'm going to continue going with the videos things, but I'll try to always have a YouTube or a Zoom like this, just in case. Okay.
Yeah.
All right. You guys feel good about this, or you want me to do another one?
I think I feel good about it.
Okay.
Thank
Rebecca seemed to just leave, so she's good with it too. All right. See you around, guys.
Bye.
Bye-bye.